All right. So now we have our next session, and to present this session with us, we have Leon with us. Hi, Leon. How are you?
Hi everyone, fantastic, thank you. Happy Sunday.
Same to you. Same to you. It's a very early morning for you in UK.
It is indeed, but what a better way to spend an early Sunday morning than with the Power BI community.
Great, 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 great. All right. So the all who are joining us from LinkedIn and YouTube Live, first of all, I would like to welcome Leon on this Power BI Delhi user groups event. So let me just start a bit introduction about Leon. So Leon is a Microsoft Data Platform MVP, and he's from UK. Also, he is a director of analytics at ONIX Data, and we can see many posts of him on LinkedIn, specifically of different Power BI report design and all. He's also running different type of contest, everyone. So yeah, that's great. And Leon is also running Power BI UK user group when different industry expert are showing the different session to the different user group event. So Leon, thank you so much for joining us here, and I also would like to congratulate for 3 years of a completion of ONIX data, which we see your post on the LinkedIn. So congratulate for that thing. And yeah, uh, again, welcome to Delhi Power BI user group. And today's session is also very interesting session, machine learning in Power BI. That is the very first time I personally saying, because this type of concept is rare to find on the internet, and very few people are exploring this kind of concept. So I'm really excited for your session. And yeah, Abhinav or Kumar, if you want to add few more thing about Leon, you are good to.
We're just excited to hear him about this great topic. The platform is yours, Leon.
Yep.
Yeah.
Thank you very much. You're all too kind, and like I say, it's an absolute pleasure to be here with you today. And also, thank you to Bernat for that session on calculation groups. It's going to be a very tough session to follow. So thank you very much for that. What I'll do, Dhruvin, Abhinav, I'm just going to put a few links into the chat for you. So as we go through today's session, some of the links I'll be referring to can just be broadcasted out to all the different social media sites.
Sure.
So just going to try and share my screen. So hopefully you'll be able to see my screen. You should be able to see Notepad++, which has now gone into PowerPoint. So just let me know if you can see my screen.
We can see Leon.
Excellent. So thank you very much for such a warm welcome and introduction. In today's session, we're going to be looking at an introduction to machine learning in Power BI. Now, this session is going to cover some technical topics, and we do have a lot to fit into a short space of time. So there will be areas throughout this session where I just gloss over some of the more technical pieces in an effort to obviously stay on time and allow time for questions. Thank you again for the very warm and welcome introduction. It's fantastic to be with you all on this Sunday morning, and I know that some of the details about what I do have already been said already, and so I'll just go over a couple of more details. For those of you that are joining us on social media, please do feel free to put in the chat where you're joining us from, and obviously what you're looking to get out of today's session. So as was previously mentioned, my name is Leon Gordon. I'm a data platform MVP. I'm very active on likes of LinkedIn, so please do feel free to reach out and follow me there. You can also follow my company on the web, which is Onyx Data. So you can find us at onyxdata.co.uk. And also, as previously mentioned, I'm currently the founder of the Microsoft Power BI UK user group, and also the Data DNA dataset visualization group, which is a monthly data visualization challenge, whereby we incentivize members of the community to visualize a data set which we make readily available every month to win some prizes. Okay, so in today's session, what will we cover? So first and foremost, we're going to understand what is machine learning, and we'll be using the acronym of ML throughout this session. We're going to look to see how we can benefit from machine learning in Power BI. how to create a machine learning model in Power BI Premium or Premium per user, often referred to as PPU. And then we'll also touch on how to create a machine learning model in Power BI for free, either using Power BI Desktop or also the Power BI Pro license. And then what I will do is I'll give you some resources after to continue learning as well. So moving in, let's take a look at what is machine learning. So machine learning is a branch of artificial intelligence, often referred to as AI, that teaches computers to do what comes naturally to humans and animals. This is learn from experience. So the key point to point out here, as is highlighted, is we're looking to teach a computer how to learn from experience. Excuse me. So machine learning algorithms use computational methods to learn information directly from data without relying on a predetermined equation as a model. So again, key information to highlight here is we're looking to put into place a computational method that allows the computer to learn information directly from data. Now we're just going to take a brief look at the history of machine learning, and then we'll be looking to go into a few demos. Okay, so machine learning actually dates back to the 1940s. A gentleman called Arthur Samuel, who was a computer scientist at IBM and a pioneer in artificial intelligence and computer gaming, coined the term machine learning in 1952. Arthur designed a computer program for playing checkers. The more the program played the game, the more it learned from its experience, thanks to an algorithm called the Minimax algorithm. It didn't take off until the late 1990s when IBM developed its Deep Blue supercomputer. I'm sure that a lot of you will be aware that do follow machine learning. The Deep Blue was able to beat the world chess champion Garry Kasparov in 1997 at a game of chess. So, with that being said, how can we benefit from machine learning in Power BI? Well, we can look at a vast array of different techniques, looking at real-time predictions, churn analysis, customer leads and conversion, and potentially being able to predict fraud. Now, in today's session, what we're going to look to do is look at how we can predict customer leads and conversion specifically. So, without any further ado, we're going to look at how we can use machine learning in Power BI with a demonstration of the premium functionality of AutoML. So to do this, I'm just going to jump over to my Firefox environment. We're going to take a look at the Power BI workspace. And if I just directly go back to app.powerbi.com, we'll load up our service environment, and we will go over to a previously created premium workspace, which in this instance is our sandbox workspace. So I do have some objects here that have been created already, but we're going to do a live demonstration and walkthrough. Now, as I mentioned, in an effort to stay on time, we're going to have to run this through quite quickly and gloss over some of the technical details. But as always, please do feel free to ask questions throughout. So within our sandbox workspace, to start to use some of the premium functionality, what we want to do is define a data flow, and within a new data flow, we can start to look at using the AutoML functionality. So to do that, we're going to take a look at new and head over to our data flow. Sorry, for some reason the service always asks me to click twice on data flow for it to be selected. Okay, so within our new data flow, we're going to look at defining a new table. Okay, so we just go to add new tables. And in this instance, we're going to take our data from a text and CSV source. Now, what I want to do, apologies, let me just get some more light back on. We haven't had a power cut, it's fine. Okay, so what I will do at this point is just go in and give you a bit of a background on the data that we're going to use for today's session. So I did previously provide some links to a GitHub repo. So within this GitHub repo, we have two data sets. So we have one data set, which is a sales training data set, and we have another data set, which is a prospective buyer CSV. And I don't think my light is going to play too well with me today, so we may just have to continue with the lighting as is. Okay, So with that being said, we're going to take a look at our sales training data. So when we're looking to put into place machine learning models and predictions, we want to, as we previously referred to, train the model to be able to understand and learn from the underlying data. So generally to do this, you have a subset of data which has the outcome that we're looking to predict already determined. So in this example, we are looking at some sales data. Now this sales data comes from an e-commerce company who have leads which they look to convert into sales. So within this data set, we have 7,820 rows of data, and we have the attributes of the person's age, their marital status, their gender, their yearly income, total children, the number of those children that are still at home, their education, their occupation, whether they're a house owner or not, the number of cars owned, the state and province code, their postal code, and this buyer flag here determines whether this individual actually brought or did not buy directly from our sales company. Now, with this being the case, we want to ingest this data via a data flow ingest this data as an entity into our data flow. So we can just head over and get the raw version of this file, copy out link, head back to our workspace environment, and we're going to use the link that we just copied as our file path or URL. Okay, we select next, and the web version of Power Query will go off and bring you back to a very familiar screen whereby we're just displaying the first 200 rows of data. Okay, we can see that all of our data is being pulled in as we've just seen it in the GitHub repo, and Power Query has already predetermined some of the data types in behind that as well. So we're going to look to transform our data next. Now, in this example, as mentioned, Power Query has correctly defined that our first row, our headers and our data types are correct. So we don't need to do any more transformations at this stage. We can just save and close. I'll give the data flow a name. In this example, let's go with Delhi user group _ MM. And we're going to save that data flow. Okay, now Power BI will ask us if we want to refresh now or set a refresh schedule. As part and parcel of this demonstration, we're not going to do either. We can see that we've got our table name being ingested into our data flow. Now, well, at least the metadata is there. And we want to have a look at our secondary data set, which I briefly referred to earlier. So we're just going to go back to our GitHub repo. Back to our repository, and in this file here we have a prospective buyer CSV. So we're just going to open our prospective buyer CSV up. Okay, now within our prospective buyer CSV, so our data set, we can see that we've got 2060 lines or rows of data, and we have a bit of different information. So we can tell that this information has probably been taken from a transactional database because we have a prospective buyer key, a prospective alternate key, but we have more information in this case. So we have the client's first name, their last name. We have similar attributes in terms of age, marital status, gender, yearly income, total children, number of those children that are at home, their education, their occupation, whether they are a homeowner or not, the number of cars owned, their city, their state province code, and their postal code. But you'll notice that within this data set, we do not have the definition of whether this individual is a buyer or not. Now, in this case, the reason we don't have the information is because these individuals are leads. Now, with these individuals being leads, it's a clean data set whereby we have not determined whether these individuals would be likely to buy from us or not. So wouldn't it be great if we could use historic data? So data of individuals that have already purchased via our company to identify, based on common attributes, whether any of these individuals would actually buy from us in future. Now, the benefit of this, if you imagine a sales company that are paying a lot of money every month for leads. Now, some companies can pay millions of pounds per month for leads from other companies. Now, as you can imagine, some of this money will be wasted because some of these leads will not convert. And also, if you are actively contacting vast amounts of leads every month, obviously, wouldn't it be great to understand if we could contact people directly, get a conversion rate that's better suited to us, and have a bit more insight into whether this lead is actually likely to convert before looking to contact them. So with that being said, we're going to ingest our raw data set. So again, this is our lead data, whereby we don't know whether they are going to convert or not. So we don't have the buyer information. We're going to go over to add tables. We're going to do the same technique in terms of using a text CSV. We're going to use our raw URL. So this is a raw version of our CSV from the GitHub repo. Go to next. And again, Power Query will just go through, do some data type detections based on the first 200 rows of the data. And then we can go in and once again look to transform our data. Now, as again was mentioned previously, in this example, we don't need to use the first row as headers. We don't need to do any further transformations because Power Query has correctly defined all of our data types for this prospective buyer data set. So we can go ahead and save and close. Okay, Power Query will just go away and validate the queries. Once again, it will ask us to refresh now or set a refresh schedule. In this example, as an effort to be mindful of time, we're not going to do that. Now, we have our two table entities defined within our new data flow. This is a perfect starting place, okay? So now that we have this, let's go ahead and look at how we can build a machine learning model within Power BI Premium or Power BI Premium per user based on our sales training data. So we're going to go ahead, we're going to go over to machine learning models. Okay, now Power BI gives you a great UI, which we can just run through. It asks us if we're new to machine learning models, which I'm sure some of us are. So what we're going to do is follow these steps. We're going to select our training data. So remember, our training data is historic data whereby we already have a definition of the outcome that we're trying to achieve. We're going to choose a model type. So as Power BI points out here, that will help us pick the best model to achieve our business goals. We'll then look to train the model. We can then look to iterate and retrain the model before applying our machine learning model for predictive insights in the future. So let's get started. Okay, so by getting started, as mentioned before, Power BI is going to ask us, what do we want to predict? So let's take a look and choose our table. So we want to use our sales training data to be able to predict our output column, which we know is our individual a buyer or not? Okay, so once we've selected those values, we can go to next. Now, as mentioned here, Power BI has recommended to us a prediction model. And in this case, it's got the prediction model correct because we're going to be doing a binary prediction. So a binary prediction is determining the likelihood of a sales lead converting or the probability of a customer responding to a marketing campaign. So binary means, is this going to be a true or false value? And Power BI has gone ahead and selected the correct model that we're looking to do. Now, if it hadn't, then you can go and look to select a different model. So we can see we have binary prediction. There's also general classification and regression. Now, as this is an introductory session, we may touch on those values in future sessions, but today we're going to look at a binary prediction. So Power BI is asking us for some more values. So we need to choose a target outcome. Okay. So our target outcome is that we want to understand in this example, is an individual likely to be a buyer? So we want to know that our buyer attribute or our buyer column is returning a true value, which is a 1. Okay. So how would we label these predictions within our model training report? So if we have a match, so if the model successfully predicts that the individual is true, it is a buyer, then we want to call this a buyer. If it does not, if it mismatches that label, then we would just change this to be not a buyer. So here we have outlined the model that we want to use in terms of predicting our machine learning model outcome. We want to identify whether the individual is indeed going to be a buyer or not. So once we've defined this, we can go ahead and select next. Okay. Now, Power BI will ask us to select the data that we want our model to study. So in here, this is going to be our column attributes that we want to use, and this is commonly coined to in the machine learning community as features. But we're going to look at columns that we think will represent a high correlation with the outcome being a buyer. So Power BI does actually go ahead and give us some recommendations in terms of columns which it feels will not help become a low correlation to give us our predicted status of a buyer. So what I'm going to do for this example is I'm going to just ignore Power BI, and I'm going to select the vast majority of the columns, and you'll see why shortly, just so I can give you some insight into some of the reports that are generated off the back of this machine learning model. So we'll go ahead and select next. Okay, and then we can give our model a name and decide how we're going to train our model. So once again, let's call this Delhi Bernat _ Okay, now with machine learning models, you're able to define a training time. So with this being the case, the longer you train your model, the more accurate the results will be. So this is correct for any kind of discipline, right? So if we were playing football or a sport, the longer we practiced and trained, we would feel that the better we would be at that activity. Similarly to Power BI or any other discipline in which you would envisage training for. Now, because we're delivering this as a live webinar, I'm just going to pull the training time all the way down to 5 minutes. And again, in an effort to protect time, we'll probably move over to a predefined and pre-deployed version of this rather than wait the 5 minutes. Okay. So again, Power BI gives us some information on what will happen next. So it will take a statistically significant sample of our data. So this is the training data that we defined earlier. Okay, so Power BI is going to use 80% of that data to train itself. Okay, and it will iterate through and understand which values or which attributes are correct when we are identifying somebody who was brought via our sales company. It will then go away and test the model on the remaining 20% and reiterate until the prediction accuracy of the report is at a good stage. Okay, so let's go ahead and save and train our model. Okay, so if you're following along at home, you'll notice that we now have our new data flow within our sandbox workspace, and we can see that data flow is refreshing in the background. What I will do is, like I say, move along to one that I've prepared earlier, just in an effort to protect time. And this will hopefully allow us to have some questions at the end, because we do have quite a bit to cover today. So I'll go into our ML webinar deployed, which has gone away previously prior to this session and trained on the same data. So once that's finished, if we were following on from where we were before, we would be presented with this screen. Okay, now this screen has our machine learning model, which would have been refreshed, and we have some buttons here that have now been enabled. Okay, the one that we want to look at first and foremost is our training report. So Power BI has gone away, trained the data, but we're not aware at the moment of how that data has been trained and any outcomes of what the machine learning model has predicted. So Power BI gives us a very nice training report, which we can open up and go through and understand in a bit more detail. So hopefully this will open up for us fairly quickly. And then we can go through some of the information in behind what this training report is actually showing us.
So Leon, if we were to train it for, the highest amount of time, so what do we do in the meanwhile? Do we, the developer goes ahead and waits for it, right? Or is it something that has to be left running down there? Like if you move away from this screen or something happens there?
No, so it's very similar to a normal data flow refresh or a data set refresh. So this will just continue to refresh in the background. Okay. You're quite fine to move away from that screen as well. Okay, so once we have refreshed or trained our model, we'll then be presented with this report. So this is our model performance report. So first and foremost, it will tell us how the model was evaluated. So you may remember that the model was going to predict based on a subset of information that was available within our training data set. So Power BI will tell you that it's gone away and tested on 1,563 records and compared to predicted outcomes. It then gives us an understanding of the model performance, okay? And it does this using something called the area under curve, or AUC. Again, that's probably out of the scope of this as an introductory session, but it's keen to understand the model performance out of 100%. Now, in this iteration, we're currently at 79%. Power BI will also show us our top predictors. Now, you may remember that earlier on in the session, I opted to keep the vast majority of the columns, even though Power BI had already recommended that there was going to be a low correlation. So the reason I did that is because we can see here our top predictors by influence. Okay, so we have age. Age in this example is going to be our key feature, followed by marital status, followed by the total children. Okay, so most of our buyers, and we're able to predict our buyers based on these different features. We can go into a bit more detail within this report to understand that with age, the most likely of ages to be a buyer with us is either 46 or less, followed by 46 to 59, followed by 59 to 71. Okay. Similarly, for marital status, we can see here that the marital status is more than likely a single person who is going to be a buyer of one of our products. And again, we can do the same for total children. We can see that the likelihood is that our buyers will either have one child, quite significantly more than any other total amount of children. Okay. So great insight into what our model is actually doing in the background. Now, just as we move on to our matrix here, now what we can see here is that our predicted buyer value. So within our model went away, and the amount of predicted buyers, which were actual buyers, here we can see was 704 rows. So we can see within this model that they actually predicted quite well what a buyer will look like. Okay, but at the bottom here, the amount of predicted buyers, which were actually not buyers, is quite high. So 859 have been incorrectly predicted as buyers when in fact they were not a buyer. And similarly, within this column here, we can see that the amount of people that were predicted not to be buyers, who were actual buyers, was 0. And similarly, this model has not correctly predicted any actual not buyers, people that do not buy with us. Now, the reason for this is two values, one being precision, the other one being recall. Now, I would just, again, very briefly touch over what these values mean in an effort to protect time within this session. Okay, so our precision measures basically at a high level the correctness. Okay, so what the recall measures is again at a high level coverage. So for example, if our precision was 98%, it would mean that the model says the prediction is positive and the prediction is likely to be accurate. A model can be overly conservative and only make limited positive predictions, resulting in a high precision. In other words, it fails to make sufficient positive predictions. This is why we also need to consider recall as well. This ensures that we're actually capturing sufficient actual positive. So when it comes to recall, a high recall means that the model can capture most of the positive predictions. But if a model says that everything is positive regardless of underlying reasoning, the recall will be artificially high and too close to being perfect. This is why we need to balance out our precision and recall to get accurate predictions, but at the same time not at the cost of missing out on too many positive predictions. So ideally we want to have a sufficiently high precision and a sufficiently high recall. So what does that actually mean in terms of this report? Well, let's take a little look. If we move closer to increasing our precision, look at our report values now. So we're now starting to accurately predict what a not buyer would look like. Okay, so with this being the case, obviously we're geared to understand in this example, we want to see how many of these people will actually buy from us. Okay, if we wanted to see how many people would not be buyers, then again we can continue to increase our precision, and we can now see that we're correctly identifying predicting people that are not buyers, that are actual not buyers in this column here. Similarly, our predicted buyers who are actual buyers in this column here, in this row, has gone down. Okay, so there needs to be a bit of fine tuning happening here to make sure that the values that you're getting are values you're comfortable with. So for the purposes of this demonstration, I'm just going to set this at 0.5 to even things out slightly before moving down. Now, again, I'm very conscious of time, so I'm just going to touch over some other areas of the report. Okay. Now, again, we can understand in a bit more detail the accuracy of the report going through the AUC curve, the ROC curve, and then obviously we have some graphs here which just go through and give you a bit more detail on the accuracy of the model against what would be a random guess. Now, I'll cover these in a bit more detail in a more advanced session, but just to be aware that within this training report, there are further details available. So again, our final tab here will tell you how the model was trained, the amount of sample rows. So if you remember, we were going to use 80% of the actual rows for training, which we can see here is 5,730 out of our sample set of 7,293, and the amount of iterations that were run. So Power BI within that 5 minutes has iterated over this data set 32 times to start to put together its predictions. Okay, so again, without touching too much on this, this is just going to be the report in the background that is generated once you build your machine learning model. Now, what you would then do is go ahead and apply your model, which I've already done on this sandbox version. So we're just going to head back to the screen that you'll be presented with once you have applied that model. Okay, so fantastic. We now have our training data, which we've applied our binary prediction machine learning model to, and we correctly started to identify what attributes, what features are needed to define what would be a buyer. That's great, but how are we going to use that on our existing lead data that we're going to push through a pipeline? Well, to do that, we can go ahead and apply our ML model. So what we want to do is apply our buyer prediction. Now we're going to use our input table. So this is the table we're going to pipe through our machine learning model. So it's our prospective buyer. We're going to call out what we want our new column to be called. So in this case, it's going to be buyer prediction. And then we're going to set our threshold. So this is the threshold that we said before, which was between recall and precision, which is currently 0.5. We would go ahead, save and apply that, and that would then in turn apply that to our machine learning model and our new data set of prospective buyers, which we would pipe through. Once again, in an effort to protect time in this session, I've already gone ahead and done that, so I will cancel this, whereby in your scenario you would go ahead and save and apply. So great, let's go back to our tables, and we have some new tables. So we have what would be a prospective buyer, enriched buyer prediction, and also our explanations. So these new tables have been generated as an effect of applying our machine learning model. So that's great. Now we can start to interact with this information within Power BI. So let's head over to Power BI. We're going to start a new report. And once it's loads, we're going to look at getting our data, which we'll get directly from our newly created data flow. Okay, Power BI data flows, which will in turn connect to our sandbox environment. And we will go for our previously created webinar deployed data flow. And here we're looking for our now enriched data set, okay? Because we had our training data, we've taken our prospective buyer information that we want to predict, and we've now enriched it based on the output of our machine learning model, okay? So again, we could go ahead and take a look at that data. We'll see that all of our columns remain the same that we were pulling through. But now we have some additional columns. So our buyer prediction outcome. So this is the outcome that we defined. So is this person likely to be a buyer, true or false? We then have our additional column, which is the scoring based on that information. So this scoring will be from 0 to 100 on how correct the Power BI machine learning model feels it is in terms of the score that it's attributed to that information. We then have another column, which is the prediction explanation. So this is a JSON column, which will just give you what Power BI has based that probability on. And then we have an additional column, which is an explanation index. Now, I'm going to go ahead and load this data again in an effort to protect time, whereas realistically, in a reporting environment, you probably wouldn't need your explanation column or your index column, okay? So we've now got our rows loaded into our Power BI dataset. I'm just going to open this up in a bit more detail. And if I was a sales manager, for example, I might want to look at a first name, a last name, and an outcome to understand how likely that person is going to be to buy from us. So with that being the case, let's actually get our outcome and use it as a slicer as well. Okay, so we're only interested in people that have a true prediction in terms of being a buyer. Now we'll see that our data set has now filtered, and if we wanted to start calling these people, then we could, because we know there's a high probability that they will actually buy from us. We can further enhance that, and maybe we want to take our prediction score, put our prediction score in as well. Just make this so you can see it a little bit easier. And we might want to actually sort that by the highest prediction. Okay, so with this prediction score, as we mentioned previously, we can see that this is the likelihood of them actually being a true positive of buying from us. So within a short space of time there, with it using Power BI Premium or Premium per user, we've identified a machine learning binary prediction model which correctly identifies the likelihood of leads to convert for us in the future. Now, obviously, this can be very powerful for businesses that are looking to predict effectively on their data, especially from a lead conversion perspective. Okay, so with that being the case, that ends our Power BI Premium Auto ML demonstration, and let's just jump back into our presentation. And what we're going to do now is we're going to make the machine learn on Power BI for free. Okay, so it's very much worthwhile noting that no machines were harmed in the making of this webinar, not that I'm aware of. Anyway, again, very conscious of time, so we are gonna fly through this at pace. But I'm just going to make you aware of some alternative tools that we're going to use to enable this within Power BI for BI Pro. Okay, so within the data science community, there's a tool called Anaconda, which is an open source distribution of Python and our data science and machine learning tools. We're going to install that directly on the machine, and we're also going to use PyCaret. Now, PyCaret is an open source low-code machine learning library in Python that allows us to go from preparing our data to deploying our model within minutes. And Moez Ali, the creator of PyCaret, is very active on LinkedIn, so I do suggest that you go and follow him, because PyCaret is a wonderful machine learning library of tools. Okay, so with that being said, we're going to jump back into our demo. I've already set up this system in preparation for this webinar, but generally you would head over to the Anaconda website. Again, the links have been provided, where you can go and download the individual edition. Excuse me. You can go ahead and download the individual edition and install that within your system. Once that's been installed, let's just take a look for Anaconda. We can see that we have our Anaconda environment here, and we're going to use the Anaconda command prompt from this moment forward as part of our demo. Now, if you are following along at home, you may find that you need to go away and install some of the Microsoft C++ build tools as well to make sure you do not get any errors. So please do go ahead and do that. The links have been provided to do so. So once you've done that, we'll be in our Anaconda environment, and you'll be presented with this screen. Now, again, I'm showing you the art of what's possible, so please do not focus too much on the technical aspect of things. But what we want to do is set up an environment for us to start to use Python, PyCaret, and these tools within Power BI. So to do that, we've launched Anaconda. I'm going to create an environment. So in this example, I'm going to activate an environment called Data Science UG, which actually already exists on this system. So we're just going to open that. But by using the activate feature and the naming condition, you will be creating your environment at the same time if it doesn't exist already. Now, we want to make sure that we've installed something called pip, which allows us to install other modules. So to do that, we're going to use the conda command, and we're going to ask it to install pip. Now, pip already exists on this system, again, so I expect this to run through very quickly in terms of already correctly identifying that pip is installed. If it wasn't installed in your system, you would see the screen go through and create all of the packages required by pip. Okay. Once we have pip installed, we can call it as a function and ask it to install the module which we defined earlier, which is PyCaret. Okay. Again, PyCaret already exists on this system, so we'll be able to see here, if it was going slightly slower, that the requirement is already satisfied, but in your environment it would go ahead and install everything required for PyCaret. So now we have our data science _UG environment, which is fully functional and has all of the packages and libraries that we need to start doing machine learning in Power BI for free. So let's head back across to our Power BI environment, and I'm going to use actually let's use a new Power BI report. Again, I do have one created already in an effort to protect time. I know we only have 15 minutes left of this session, but we are trying to cover off every eventuality of machine learning and Power BI in a very short space of time. So with this being the case, I'm going to not use the UI helper, because what we want to do is, as I've mentioned, we've already defined our environment, our Python environment, but Power BI is not aware of that yet. So we need to go to File, our Options and Settings, head over to Options, and we are going to go to our Python scripting, because in this example, we're going to be using Python. If you haven't set up a Python directory already, then I recommend that you select Other, and we're going to set the Python home directory to our newly created data science UG environment. This is generally found within your users and Anaconda directory. And as I mentioned, because we've just created our new environment, we now want Power BI to be aware of that. Okay, so to do that, we set it as our Python home directory here. Now we click OK, and that's it. Power BI is ready to interact with our newly created Python environment. Fantastic. Now we need to go away and get some data. Okay, now using a very similar scenario to what we had earlier, we're going to go and get our data from our GitHub repo. Now, in this example, because we're not using Power Query online, we have to actually define a web connector as opposed to, in the previous version, a CSV connector. Now, we could do this locally, but again, in an effort to protect the time within this session, I didn't want to mess around with gateways, etc. as well. So let's head back to our GitHub repo. Okay, we'll go back to our repo root directory, and similarly to previous, we want to use our sales training data set. Okay, now again, we are going to fly through this at pace, so we want to go back to our raw file and gather our raw CSV. Okay, I'm just going to take this back to the root as well, so that's ready for us when we're ready for the next data set. And we're going to use our raw CSV again of our sales training data to pull that information down from GitHub, and we can see that we have our data set. Okay, now unfortunately, Power Query in a desktop hasn't interacted with this data set in the same way that it did on the web version. So we don't have our first rows as headers. So we need to go away and transform the data. Okay, so within this example, let's use our first row as headers rather than them be called column 1, 2, 3, 4, etc. And we can also see that our data types are also incorrect. So we need to go away, select our data types that we want to be defined as, in this case, just going to define them as whole numbers. Okay, and then in this example, we would have what would represent our data, our training data set on that we went through previously on Power BI AutoML, and that's great, right? We've defined this data set locally, but it's no good to us without running a Python script. So in this example, by going to the transform menu item, we now have run Python script. Now I've pre-prepared these Python scripts for you. Some of these are based on the modified versions from my friend, fellow MVP, Luca Zavarella. So fantastic work. His book is called out within our links as well. So please be sure to pick up his latest book on integrating Python and R within Power BI. And I'm just going to jump back across to, let's go to VS Code. Now these scripts are available within the Power BI repo, so you can download them directly as well. So with that being the case, I'm going to gloss over again. We've only got 10 minutes left of the session. I want some time for questions. What we're doing here. So within this script, we're basically going to encode our underlying data set to map our values to ordinals. Okay, so what I mean by this, and again, in an effort to protect time, apologies, we are trying to cover quite a lot. So we can understand that, for example, our number of cars owned, there could be 4 or 5 values within here. Now we're going to map those values to indexed identifiers. So for example, 2 will become 1, 3 will become 2, etc. So we're categorizing all of our unique values into unique identifiers. So we're just going to hit OK on that. Now this might take a moment in the background. It will ask you about your data privacy. We're going to hit continue, and we're going to ignore privacy levels for the purpose of this demonstration. Now that Python script will go away and run in the background. I do have another version of this prepared if this does take more than a minute or so. So what's happened here is now the Python script has been run, and we have 3 new data frames or data sets which have been created off the back of that script. The one that we're interested in this example is our imputed table. So just by opening this, and you'll see that all of our previously whole number values have now been converted to decimal values. And we'll see, for example, here our gender category, which we know has male and female, is now either a 0 or a 1. Now, this is really key in terms of being able to push this through our machine learning script, because we have to have decimal values to be able to do that. So let's go ahead and look at our next script, which in this example is going to be train our data set for ML. Now, again, just glossing over the technical aspect of this, this is very much more of the art of what is possible. An introduction to this can be done in Power BI for free, as opposed to what we're going through and doing here in too much detail. But just to gloss over it, we're basically calling our PyCaret library, as well as some other libraries. We're defining some of our attributes. So in this example, some of our features that we saw previously in the Power BI AutoML is age, marital status, number of cars owned, and we're basically building our model, our binary prediction model, off the back of this information. So exactly the same as what we did in the Power BI workspace in Premium. We're passing through our training data set, in this instance using PyCaret to build our machine learning model. Now, in this example, we're going to output two files, one being a saved version of the model as a pickle file. Now this is very important because we're going to use this to run the data we want to predict through in the future, and we're also going to export a CSV version of this file as well, just so we can see the data that we've trained. Okay, so let's go ahead and copy this out, and we're going to have another Python script which we're going to run here. And we're going to paste this script in and hit OK. Now, again, this is going to run through. Hopefully, it's not going to take too long. If it does, we'll just revert back to the already completed version. And I'm sure because we're flying through this at quite a pace, there's going to be some outstanding questions. So I'm trying to get through this as quickly as possible in an effort to stay on time. So please just do bear with me. Okay, as this is going to take a moment to complete, I'll jump over to our version that already has this in place, which is our PyCaret demo. We can see that we have our sales training query here.
So hey Leon, till it downloads, we have one question from Mayank Sani on LinkedIn Live. So he asked, what's the main difference between ML using Power BI and Azure ML Studio, since both provide low-code functionality?
So ML in Power BI is a great question. ML within Power BI in the service is actually using AutoML, so the same functionality as Azure ML Studio in the background. It's just from a UI perspective and using it from a Power BI perspective, but in the background they're using the same functionality. Hopefully that answers that question.
Yeah, that helps.
Excellent. So in terms of our sales training data, once the Python script that we just put in place has run through, we'll be presented, as we can see at the end here, with new columns. Okay, so very similarly to what we did in Power BI in the service. So excuse me. In the service with the workspace, we now have our new columns. So we have our label, which is it's basically our outcome prediction in this example. So predicting whether the individual is actually a buyer or not. We have the prediction score in behind that, but by doing it this way, we do not have an explanation within this. Okay, so once we're happy with that, we can see that PyCaret has gone away and correctly run the predictions. We would then be able to go ahead, close and apply, and that would have our sales training data set modeled the machine learning model and ready for us to push through our perspective bar data set. So just going to jump back and see if this is completed on our previous version. It hasn't, so I'm just going to run ahead with what we have in place on our loaded version already. Okay, so great. Once again, we have our sales training data, which has been run through our machine learning binary prediction model, and now we want to understand how we can run our new lead data through that pipeline. Now, you may have seen previously that we had an output which I mentioned was a pickle file. Now, if I can just jump back over to that folder that we defined, and I'll grab that from VS Code. So we defined the output of a pickle file and a CSV to a local directory. Okay. So we're just going to jump across to that. Let's switch our view. Let's just go to details. Let's look at date modified. And so in here, we have two new files. So one that we mentioned previously, which is our sales model CSV. So this is our training data set, so the output of the data that we've trained on. And we also have our pickle file. Now, our pickle file is just an object, basically a saved object of our machine learning model. Now, we need to use that file to pipe our data set through so that we can correctly look to predict new data being ingested through. So to do that, again, we're going to utilize PyCaret. Now, we would go ahead and our prospective buyer data set, we would go away and ingest in exactly the same manner as we did previously. Now, I've already done that in this example, but we would be getting data from our web URL using our our prospective buyer raw CSV from GitHub, promoting our headers as we did previously, and then we will start to look at running it through our Python script. And if I can, I would like to just run through that process if this is finished loading as of yet. Okay. So this has finished the Python script on our walkthrough, and hopefully I'm not losing anybody. But we can go ahead and open what we had previously, which was our predictions table, because I would like to show you this end-to-end in Power BI if possible. Dhruvin and the rest of the team, how are we doing for time?
So, Leon, you can take your time, no worries at all. We don't have any session after yours, and people are really enjoying the things. So we are good on the things.
Okay, excellent. Thank you very much. Like I say, this is quite a lot to fit into a short space of time, so I do apologize.
No worries at all, Leon. We can understand that, and the session is really interesting, and we are really enjoying the things. So please take your time.
Excellent. So with this being the case, hopefully this predictions table will open for us relatively quickly. I'm actually using the laptop today as opposed to the desktop, so we're slightly lower on compute power than normal. But again, the end-to-end of this generally doesn't take too long from a Python perspective. As I mentioned, once that does load, the output of the file will look exactly the same as what we just saw in our ready-made file, whereby we will have, we just go to sales training, we will have our new columns. So this will be our label, which is our score, our true or false value, on whether we believe that the individual would be a buyer, and the scoring behind that. And this is really key because I would like to show you how we pull in our new data and run that through the pipeline also. I'll tell you how we'll do it instead. Actually, let's go back to our demo, and I'll just recreate the existing table here. in this scenario, just so we can see it in practice. So let's go away. We want to get some data. We're going to use our web connector, and again, as I mentioned, we want to pull in our prospective buyer information. So let's go back to our GitHub repo, and we want our prospective buyer CSV. So remember, this is our new leads, okay? So this is leads we don't have a score against. We don't know if they've purchased with us previously. This is new lead data that we're looking to pull in. We're going to go to our raw version, which will give us the information we need for perspective. And we're going to go back and use that as part of our get data. Okay. Now, again, very similarly to our last example, Power BI will pull that information in. We don't have our first row as headers, so let's go ahead and look to transform that data. Now, in this example, as I mentioned, because we have an existing version of this created, we do have our new version here, which has been defined as 2. But we're going to go ahead and just follow the steps, just so it makes it a bit easier for everybody at home to follow through with as well. So let's change our first row to be headers. And in this example, again, our data types are incorrectly defined as strings. So we're just going to go ahead and quickly change these into numbers. Do that. Okay, let's transform that. And the data type we're going to choose, as I mentioned, will be a whole number. So great, we have our new leads and data set imported into Power BI. Now, very similarly to what we did previously, we need to re-encode these values to be able to run them through our machine learning model. So once again, to do that, we're going to use a Python script. Again, I've defined a script for us already within the GitHub repo, which is available within the comments. So please do feel free to go ahead and grab that file. Just go back to our GitHub repo root directory. And in this example, we're going to use the impute new data set for, let me just take a look in VS Code. Just so I make sure I'm giving you the correct data set. Okay, so we need to use the impute new data set for prediction script. Now we're just going to jump back into our Python script and paste this in and then hit OK. Now in the background again, the Python script will just run on this data set. It's going to look to encode these values, as we mentioned previously, into these decimal values ready to be run through our machine learning model. Okay. Again, hopefully this shouldn't take too long, which is great. And we now have, as again, very similarly to our sales training data set, we have our free data frames or data sets being made available, and we can go to our imputed data frame or data set and open this up. Now again, just while this does this, I'll get the next phase ready, which we're going to run another Python script, which is going to pipe our data set through and start to enrich it in exactly the same way that we did on the Power BI service, enriching our lead prospective buyer data set with our predictions. Okay, so again, as we can see here, all of our values have now been mapped to decimal numbers. We can go back to our scripts, and we want to train data set for pipe data set for training. So within our final script, and I'll just update this so it looks exactly the same as what it is on repo. Within our final script, we're going to once again use PyCaret. We're going to use our pickle file. So you remember we defined our machine learning model as a pickle object earlier in the session, and we're going to load our current model against that and then use our predictions to identify within our leads which of these will become buyers. Again, very much glossing over the technical aspect of this, just showing you what is possible within Power BI, and potentially we can go into a bit more technical detail in a future session. Okay, over to our Power BI PyCaret demo. We now have our imputed data set, and we want to run our next Python script. This is our final Python script, and we hit OK. Now, what will happen is exactly in the same way that AutoML was working on the service, we're now running our new leads through our machine learning model to identify and predict out of those leads which ones are likely to be buyers and which ones aren't. Okay. So this will just go ahead and run in the background. And again, in an effort to protect time, I'll go ahead onto the one that's already previously been put in place, hopefully. We've got a little race on which one's going to actually load first now, haven't we? And this one looks to have won. So we have our two new tables, and we want to have our predictions table expanded to give us our final data set. So we're just going to go ahead and expand this, and then we'll be able to visualize this information in Power BI in the same way that we did with the premium versions, and then we can open up the floor for any questions. Again, we just see our race on which one. Because I would like to show you the finalized data set. Okay, excellent. So we have our prospective buyer data set here. As we can see, we have all of our values that are encoded. And if we just scroll all the way to the end, we can see that this information has now been enriched with our label and our score information. So again, this is our lead prospective data set, but we now have the additional prediction columns of whether we feel that this lead will be a buyer or not, and the score in behind that. So I'm just going to close this. In your example, you would close and apply, but I've already loaded this data. So let's just go ahead and close. We're not going to apply any changes. So we're going to go to our prospective buyer table, and let's pull in our label value, which in this example is true or false. Okay, we just change it into a slicer, so we want to have everybody who's true. And again, in this example, we do have encoded values as our first and last name. So if we were to look at actually getting our true first and last name values, we'd be using our keys that we already identified earlier within our transactional database to then fold that information back in. But just to show you and complete an end-to-end of demonstration, sorry, outcome label. Fantastic. Okay, so again, this would give us our list of correctly scored first, last name, and people that are most likely to buy with us. And again, we can just put our scoring in there as well, and sort by our scoring to identify which are going to be the most likely to buy with us. So again, this is a way to look at how we can do AutoML for free on Power BI Desktop or in Power BI Pro, but also, as we saw earlier, the premium functionality that is available to us out of the box within Power BI. So just to jump back to our slides, because I know that we're over time, so I really apologize for that. So let's just jump back to our place. Interesting topic, so I do apologise that we've gone over time with it, but I'm keen to obviously make sure that we get the most possible. So we now have a vision. Okay, so here's how we can take it to the next level or a new level within Power BI. So we have other aspects of machine learning which could be available to us. So there could be outlier detection, topic distribution, or association rule mining as well, available to us within Power BI using libraries like PyCaret. We have some more resources available. Again, I've linked these within the chat. So please do feel free. As I mentioned, go ahead and get extending Power BI with Python from my friend Lucas Avarella, and also KD Nuggets towards data science, and obviously Microsoft as well have a lot more information available on the topic. So with that said, I'm just going to open up now to any questions.
Sure, Leon. So actually, it's a very amazing session. Everything is very crisp and clear, and we should know like how capable Power BI is to deal with the Python and how beautiful thing we can achieve with our existing report. So I know it's to get together all this information into a single session. It's a huge effort, and you did it very nicely. And the session is something like at any minute I don't feel that I should miss anything from your session. So it's hats off to you for bringing together everything into a single session. And after this session I'm specifically keen to learn more about Python thing, and more about this ML model, because machine learning is obviously everyone's favorite topic nowadays. So definitely going to explore that. And yes, we have received couple of questions, so let me just go through the question from different social media handles. All right. So the first question I think you already covered, but still let me mention here. Like, do we need any specific license for machine learning in order to use in Power BI? That is the first question from YouTube Live.
Okay, no problem at all. So let's define what we mean by machine learning in Power BI. So what we've explored in today's session is two variations. So to answer that question broadly, as we've seen, we do not need to have a license to use machine learning in Power BI. Now, by using Power BI Desktop for free, or Power BI Pro, which Power BI Pro is a paid license, but it's not required for this, we can use Python and PyCaret alongside Anaconda as well, to create a free version of machine learning. Okay, now to use the auto ML in the Power BI service that we went through on the workspace and define in a data flow a machine learning model, you have to have either a premium license, premium capacity, or premium per user, the PPU license. Now it's worthwhile noting that if you do use either of those, so either premium capacity or premium per user, that functionality will only be available to other people who also hold a premium capacity or a premium per user license within your organization.
Perfect. So the answer is very clear. Hope the audience get the answer. Second question is like one thing that you have shown using data flow. So the question is that once we define one model using that data flow, after that you applied the different table within the model that you develop. So can the single model can apply on multiple tables? That is the question.
That's correct. So let's envisage that we had I don't know, a leads table that was being defined every month. So rather than having a single leads table, we had a new CSV that we wanted to import every month. Then yes, we could, in exactly the same way, by just using a different version of that table, apply it to the same apply the same model to different lead tables. Now, with that being the case, we need to understand and make sure that a lot of the attributes are similar. So you would have seen within my example that the attributes in terms of age, occupation, postal code, etc., were all common attributes between the training data and the lead data being ingested. So just make sure that you have common attributes and you will be fine.
Great, thanks. The third question here is like, can we apply machine learning model for direct query data sources?
Very good question. I don't see why not. because you would still be ingesting the data in exactly the same way. It's not something that I've tried, to be quite honest with you. I tend to avoid direct query as best practice, but great question, and something that I will try out ahead of a future session. And if you do know the answer to that in the meantime, then please do let us know. But I would fathom a guess that it would still be achievable.
Okay, thanks. And the last question over here, I can see, like, when we publish the report to Power BI service with Python script executed, then do we need to install any gateway or anything like that?
This is part of our more advanced session, so I'm not going to answer that directly
Okay.
in this session. So one thing to be aware of is we used web data.
Mhm.
As opposed to using a local CSV file, we used a web URL to avoid using the gateway as part of this session. So with that, some of the obstacles to overcome, if you're going to use local files, would be the gateway. Also, another obstacle to overcome is the versioning of Python and the loading of the packages within the service. So something that we touch on in a more advanced session.
Okay, great. Thanks. So I think these are the question from different live platform. So yeah, by seeing the question, we can see like audience really connected with your session a lot, and they are asking very good question for your session.
Fantastic. Well, thank you very much for having me. As we said at the top end of the session, if you do want to connect with me, then please do feel free to reach out either on LinkedIn, via Onyx Data, the Power BI UK user group, or the Data DNA Dataset Visualization group. As I mentioned, it's been fantastic to be here with all of yourselves at the. I'm just going to stop sharing my screen, so I can actually see you all. It's been fantastic to be here with you all at the Delhi Power BI user group. So thank you very much for having me. I'd love to be back again in the future.
Absolutely, Leon. We would love to have you again in our upcoming session with some advanced machine learning and more session related ML. So thank you so much for providing your most valuable time in this morning, and you made our Sunday very knowledgeable. Actually, we learned a lot during this particular session.
Excellent. Thank you very much, and enjoy the rest of your Sunday. And thank you to everybody that's tuned in as well. Really good to be with you on this Sunday. So thank you.
Thanks a lot.
Thanks, Leon. Thanks a lot.
Bye bye.
All right. Bye bye. All right. So now I request Abhinav to just give the ending speech for this event.
I think we are good, Dhruvin. I think we are good. So everyone has learned a lot today, and this would be available. These sessions would also be available in recorded formats on our LinkedIn Live pages and on the group pages for future reference. So if anybody has any further questions down there, they can go down there and post their in comment sections, and look out for Git repository links that Bernat and Leon have provided for further hands-on on these. And definitely, as they mentioned, that you could also reach out to them, or even we will try to answer those if any you come across any questions or doubts around that later on. So thanks again for joining all today. With this, we'll close this session for today. Have an amazing rest of the day. Bye.
Absolutely. Thank
Thanks,
you so
everyone.
much, Abhinav. Thank you so much, Abhinav. And for next month event, we will declare soon on our all social media handle. Most probably in February, we would be having one big event for Power, specifically for Power Platform Day. So which would be approximately the third week of the February. So stay tuned with us to our next event. Till then, have a great day. Goodbye and happy weekend to everyone.
Thank you.
Thanks, everyone. Thank you.
Thank you, Dhruvin. Bye-bye.
Soyez.